Hey, it's Matthew Giorgio. You ever wonder how games are designed? How monsters and characters in games are given what appeared to be intelligence? I'm going to show you exactly how that's done in a very, very simple way. Very, very simple way. How monsters and characters are given intelligence, artificial intelligence. Although if you're an AI person, don't jump on me. This is going to be very simple method of demonstrating how this. So let me show you. I'm going to write it down in my notebook and you can follow along. Very simple. Don't be scared. This is easy. Check it out. All right, let me use a Sharpie so you can see this better. All right, so let's use the example of Pac-Man. You guys remember Pac-Man, little circular character, little pie-shaped character, and he was eating dots. And every once in a while, he'd encounter these ghosts that wanted to eat him. Right? So how were these ghosts programmed to interact with Pac-Man? Here's how. So the ghost would move around a maze, Pac-Man would move around the maze, and the system was constantly determining how far the ghost was from Pac-Man. How far, how close. And depending on that distance, a ghost would respond in a particular way. So some ghosts, what they would do is they would attack. They would attack Pac-Man. And some would run away. Okay? So how do we program this? Very simply, what we do is we create a list. A list is just like a bracketed list of items. Just like you see here. Attack, comma, run. It's a list of 2 items. And when the programming code was checking constantly the distance, and it would determine, how close they are. Once it reached a certain level of closeness, let's say it was, 300 pixels, the system would choose between one of these 2 options for this ghost to react in. And I'm not saying this is exactly how Pac-Man specifically was programmed to work. I'm just talking in general here. So in this example, the ghost would either attack or run. So how do we pick an item from this list? Well, in programming, what we would do is you just choose a random number. So we would do a random, and I'll just use to simplify this, I'll do random 2. The reason I'm doing random 2 is I'm trying to pick a random number between 1 and 2. So when I run this function, random 2, it's either going to return the number 1 or the number 2. Now notice in this list, attack is in my number 1 position, and run is in my number 2 position. Now, hardcore programmers will say this is a 0 position, and that's the 1 position, but I'm trying to keep this simple. So, we determine that the ghost and Pac-Man are close together. We fire off random 2. It returns 1. We look in our list, and 1 is attack. That means the programming code now tells this ghost to attack Pac-Man. How does it attack Pac-Man? Well, it figures out the direction that Pac-Man is in, using just some simple math, and then it actually follows that direction. So that way it's now following Pac-Man. If instead our random number was 2, we would choose run. So what does run mean? Well, it means figure out where Pac-Man is and go in the opposite direction. So move in the opposite direction because now you're running away. So this simple list can work in a variety of formats. Let's say we were simulating the weather. Option 1 could be sunny. Option 2 could be rainy. And you do a random number, and if you pick 1, it's a sunny day in the simulation. Pick option 2, it's a rainy day in the simulation. Now, let's expand this and make it a little bit more complicated. What if we wanted this monster to attack more often than it ran away? Well, we would create a list that has attack. I'll just use letter A for that, for abbreviation. Attack, and then run. So I have a list again but now I have 3 items. Attack, attack, and run. 1, 2, 3. So I would do a random 3. So now it's going to pick a random number between 1 and 3. If it picks 1, it's going to be attack. If it picks 2, it's going to be attack. If it picks 3, it's going to be run. Now notice we've changed the probability of this monster attacking. Here was 50-50 chance. 50% chance attack, 50% chance run. Now we've increased the probability of an attack, in fact, to 2/3. So it's a 66.666 chance that the monster will attack and a 33.33% chance that it will run. Now, we could expand this even further. If we wanted it to be a 75% attack, 25% run, we would just add another A in here. We'd have 4 in the list. 3 of the 4 are attack, which means 75% chance of attack. So here's what's cool is we could design this as one monster. Let's say this is a really aggressive monster, but then we could also design a really passive monster, a little, scaredy cat monster. And the scaredy cat monster is going to mostly run. So look, we could have a list with a bunch of runs in it and only one attack. So in most cases, this monster, in fact, 80% of the time, it's going to run away because it's a scaredy cat monster. And only 20% of the time will it attack. So now what you're doing is you're creating different behaviors for different monsters and giving them personalities. The other thing you could do too is you could design, using the same list approach, how a monster reacts when they see Pac-Man, when they're close to Pac-Man. So when Pac-Man gets within 300 pixels, what's your monster going to do? Well, you could say, well, I want the monster to jump. I want the monster to stomp up and down. I want the monster to twirl. So you create a list of different actions that you want the monster to do. Now, of course, you have to program these actions. So a jump, you'd have to design or write a little bit of code for the little monster icon to move up and down. Or stomp, maybe you design a little graphic of a little foot or something that comes out of the monster and kind of stomps their foot down. A twirl, the monster does a 360, so you get your graphic designers to do a few different frames of the monster turning around. But this is the intelligence. The intelligence is a simple list. Again, I'm simplifying artificial intelligence here, but this is exactly how it starts out. So you simplify that list. Now, moving on to our GoVenture simulation, I've designed a lot of business simulations. They're called GoVenture. How do we apply this? Well, I mentioned the example of weather. Another thing you could apply is the example of a customer behavior. So a customer walks into a restaurant, and let's go ahead and switch to another page here. So we have a customer. Customer walks into a restaurant. And the restaurant has a menu. And the menu, where's it going to be in a list? So we're going to say a burger and a wrap. So the customer walks into the restaurant. What are they going to order? Are they going to order a burger or are they going to order a wrap? Well, if I have a list of 2 items, this is 50-50 chance. I do a random number and I choose what that customer is going to order from the menu. Now, I could have this menu as long as I want. I could have 10 items, 100 items, 1,000 items. I can also have different customers with different consumer buying habits, right? So I could say, well, this customer has a greater likelihood of ordering a burger rather than a wrap. The customer doesn't eat salads, doesn't like wraps, only likes burgers. I could have a customer defined using a simple list like this as well that says they are more likely to buy a burger than a wrap. You can even build these lists dynamically as well. So rather than having them fixed, you could actually have the code build the list and define the customers in real time. So every customer that comes in has a completely different personality or buying behavior. And so you can apply this to everything, weather, customer buying habits. You could have different prices for products. If you're going to order from suppliers, maybe their prices fluctuate up and down. You could have stock prices this way. So it's a very simple way that uses lists of behaviors and properties and then random numbers to choose something from that behavior, and then the code executes on that. That's the simple explanation of how you can design a game, a simulation with intelligence and characters. I'm Mathew Giorgio. Hope you found that interesting.